So welcome to review quiz 6 of Calculus 2, a topic of converging and diverging of sequences using limits. So we will note this limit as a sequence n welcome to review quiz 6 of Calculus 2, and the topic is converging and diverging of sequences using limits. So we need to note that the limit of a sequence as n approaches infinity equals to L, that sequence converges. And a sequence diverges if we find the limit of that sequence and we get that the answer that the solution is that the limit does not exist, or it's plus or minus infinity. For the first one, we have an equals, or the sequence an equals to limit equals to natural log of n to the power of 4 divided by 5n. So we find the limit as n approaches infinity of ln of n power 4 over 5n. So we use the properties of natural log. So we take 4 in front of natural log. We have 4 natural log of n divided by 5n. And then we can factor out the number 4 over 5. And then we find limit as n approaches infinity of natural log of n divided by n. We find that by inspection, natural log of n over n, as n becomes bigger, we have infinity over infinity. So that means it's indeterminate. So that means we have to use the L'Hopital's rule, which we discussed in the previous sessions. And that means we have 4 over 5 limit as n approaches infinity. We find the derivative of the numerator. That's ln of n, which is 1 over n. That is derivative. And derivative of n, that is 1. And then we substitute n as n approaches infinity. And we find that this function will go to 0. So we have 4 over 5 times 0, which is equals to 0. And that means that the sequence an, which is natural log of n to the power of 4 divided by 5n, converges. The second one, it's an equals to n multiplied by sine of 1 over n. So we find the limit as n approaches infinity of that function. And we find that if we do the inspection first, we find this is an indeterminate form of the type infinity times 0. So that means we have to use the L'Hopital's rule again. So we rearrange this in a way that we have sine 1 over n, which will give you the 0 in the numerator, divided by 1 over n, which will give you a 0 in the denominator. And then we do find the derivative of sine 1 over n, which is first cosine of n, cosine of 1 over n, then you multiply by the derivative of what is inside the cosine, which is derivative of 1 over n, which is minus 1 over n squared. Then we find the derivative of the denominator, which is minus 1 over n squared. And those we cancel to get cosine of 1 over n. But we know as n becomes bigger, 1 over n goes to 0. So we have cosine of 0, which is equals to 1. That means, again, that the sequence an, which equals to n multiplied by sine of 1 over n, converges because you are getting a number. For the third one, an equals to 4n divided by the square root of n squared plus 8. So we first check that the highest power of n is n in this case, because square root of n squared is n. So we divide by n on both numerator and the denominator to have 4 divided by square root of n squared plus 8. This is the dividing the denominator by root of n squared because it's the same as n. So we rearrange the denominator to have only one square root sign. And because we are dividing by square root of n squared, we can put one root sign, and we have n squared plus 8 divided by n. So this simplifying, we have limit as n approaches infinity, 4 divided by square root of n squared over n squared, which will give you 1, plus 8 over n squared. Then, as n becomes bigger and bigger, 8 over n squared will get a 0. And that means that 4 over square root of 1 plus 0 is equals to 4. And that will tell us that the sequence an, which equals to 4n divided by root of n squared plus 8, converges. Let's do number 4. So we find the limit as n approaches infinity of n plus 1 factorials divided by n plus 2 factorials. So what we ought to remember is that n factorial is the same as n multiplied by n minus 1, decreasing all the way until we have 1, then times 0 factorial. A good example, if I was to tell you to give 8 factorial, is the same as 8 multiplied by 8 minus 1, that's 7, multiplied by 8 minus 2, that's 6. That way, 8 minus 3, that's 5. 8 minus 4, that's 4. 8 minus 5, that's 3. 8 minus 6, that's 2. 8 minus 1. 8 minus 7, that's 1. And then 8 minus 8, that's 0. And 0 factorial is always equals to 1. So doing like that, so we can have that this is the same as, if you are to simplify, the same as limit as n approaches infinity, n plus 1 factorial, it's smaller than n plus 2. So you can write n plus 1 factorial in the numerator, and then I check the denominator, n plus 2 factorial is the same as n plus 2. Reduce 2 by 1, you get n plus 1 factorial. And then you can cancel n plus 1 factorials to give you limit as n approaches infinity of 1 divided by n plus 2. What will tell you that as n increases, this will go to 0 because the denominator will increase. So again, this one converges. That means that the sequence an equals to n plus 1 factorial divided by n plus 2 factorials converges. So the meaning of that is that if I give the n factorial, it's the same as n multiplied by n minus 1 factorial. Finally, an equals to n squared, n to power minus 2 exponential power 2n. So we find limit as n approaches infinity. N power minus 2 can be written as 1 over n squared exponential to the power of 2n. So this is the same as finding limit as n approaches infinity, exponential power 2n divided by n squared. If we do the inspection, we have that exponential power infinity is a big number divided by also a big number. So that's infinity over infinity. We have to use the L'Hopital's rule. And that will give us limit as n approaches infinity. Derivative of exponential power 2n, it's just e power 2n. Then we multiply by the derivative of that power of the power, which is 2n. So derivative is 2. Then we do the denominator. The derivative is equals to 2n. So simplifying, we can cancel 2's. And then this results to limit as n approaches infinity of exponential to the power of 2n divided by n. Again, we still have indeterminate form. So we do another L'Hopital's rule. Limit as n approaches infinity. And the derivative of the numerator, again, it's e power 2n multiplied by the derivative of the 2n, which is 2. Then we divide by the derivative of the denominator, which is now 1. So we have that this is the final part, which is equals to the limit. I can factor out 2 to have 2, then limit as n approaches infinity of exponential to the power of 2n. And we find that as n becomes big, as n grows, then the exponential function will grow also. So we have a very big thing, and this becomes infinity. So this function diverges. The sequence an, which is equals to n power minus 2 exponential power 2n, diverges. That's the end of review quiz 6.